we have learned that a force is needed to change the speed or the direction of motion of an object. What do you observe when an object is dropped from a height? It falls down towards the earth. Why? Isaac Newton could grasp that a force is responsible for this. This force is called the gravitational force. So, every object dropped from a height will experience a gravitational force of the earth. Therefore, the object falls down towards the earth. We know that the moon goes around the earth. An object, when thrown upwards, reaches a certain height and then falls downwards. It is said that when Newton was sitting under a tree, an apple fell on him. The fall of the apple made Newton start thinking. He thought, if the earth can attract an apple, can it not attract the moon? Is the force the same in both cases? He conjectured that the same type of force is responsible in both the cases. But in the case of moon, it does not fall towards the earth. Why is this so? Let us try to understand through an activity. Take a piece of thread. Tie a small stone at one end. Hold the other end of the thread and whirl it around. Note the motion of the stone. Release the thread. Again, note the direction of motion of the stone. Before the thread is released, the stone moves in a circular path with a certain speed and changes direction at every point. The force that caused this acceleration and keeps the body moving along the circular path is acting towards the center. This force is called the centripetal force, meaning center-seeking force. In the absence of this force, the stone flies off along a straight line. The motion of the moon around the earth is due to the centripetal force. The centripetal force is provided by the force of attraction of the earth, that is, the gravitational force. Now, coming back to the question of why the moon does not fall on the earth's surface due to this gravitational force. A rotating object will have a force applied on it in the outward direction. This force is called the centrifugal force. In case of the moon also, the centrifugal force is acting outwards, while the gravitational force is acting towards the earth. These two forces balance each other, which keeps the moon revolving around the earth in its orbit. Now, let us recall that a falling apple is attracted towards the earth. Does the apple attract the earth? If so, why do we not see the earth moving towards the apple? According to the third law of motion, the apple does attract the earth, but according to the second law of motion, since the mass of apple is negligibly small compared to that of the earth, so we do not see the earth moving towards the apple. In our solar system, all planets go around the sun. There exists a force between the sun and the planets. So, Newton concluded that all objects in the universe attract each other. This force of attraction between objects is called the gravitational force.